Good morning, students. Today, I want to talk about a hypothesis test about a mean. We've been doing proportions, so this is going to be an example of a t-test of one sample. Okay. For our example, I would like to use the local Chamber of Commerce example. I'll read it out loud. Make sure you have this worksheet in front of you. A local chamber of commerce claims that the mean sale price for homes is $90,000. A real estate salesperson notes a random sample of 8 recent sales listed here: 75,000, 102,000, 82,000, 87,000, 77,000, 93,000, 98,000, and 68,000. How strong is the evidence to reject the Chamber of Commerce's claim? Okay, so this is a hypothesis test, so we need to begin by stating two hypotheses. The null hypothesis is not a proportion anymore. It's going to be based upon a parameter, which is a mean. So we're going to be using the mu symbol. The mu is going to be equal to something in the null hypothesis, and the original claim is that the mean sale price is 90,000. Okay. The alternate hypothesis is always using the same parameter, but it's not equal to that to the original hypothesis. So then we have to decide, is it going to be less than, is it going to be greater than, or is it just not going to be equal to? In our question, they're basically testing the claim, but there's no hunch of which direction the actual mean will be. So my alternate hypothesis is just going to be a not equal to sign. In other words, this is going to be a two-tailed test. Okay, so let's begin modeling, which means let's go through the conditions necessary to perform the one sample t-test. Okay, do we have a random sample? Yep, it's stated random sample. The sales doesn't say that they're independent, but we can just use the independent assumption for that. The 10% condition: 1, 2, 3, 4, 5, 6, 7, 8. We have an 8 sample of recent sales, so that 8 sales is definitely less than 10% of all sales. There's definitely more than 80 sales in the world, so the sample size we have is not being too large. Because we don't have a very large sample size, we cannot just use the central limit theorem for showing that we have a distribution that is nearly normal. So we have to actually take a look at what the distribution looks like. So on our calculator, let's enter in the raw data. Stat edit under list 1, enter in the 8 sales, 75,000, and so forth. Okay, in order to look at the distribution, I'm going to do a stat plot. Let's turn it on, choose the correct histogram. My lists were under L1. Yeah, looks good. Zoom 9. And it doesn't look outrageous, but it's going to look good enough for me to say that this looks nearly normal. It's a very small sample size, so it does look like it's skewed a little bit to the left. This is a frequency of 1 and 2, but it's not totally outrageous. So I'm not saying it's normal. I'm just going to say that it's nearly normal. It's meeting the nearly normal condition. And my evidence is I'm going to sketch a histogram that shows that the distribution of numbers is nearly normal. It's random, it's independent, it's small enough where it passes the 10% condition, and the distribution of numbers is not large enough to use the CLT, but the actual histogram looks nearly normal enough. We may now proceed with the one sample. Oh, not z-test anymore. This is going to be means, the one sample t-test. Okay, for the mechanics. Okay, do we have an X bar? Stat If we go to the calculator under test, you can actually find the t-test as the second choice. It's not called a one sample t-test on the calculator. We're just going to be using the t-test. Okay. Do we have parameters? In the previous question, they gave us parameters that we can plug in, but we actually have the raw data. So I'm going to make sure I use that. Oops. Data. What was my null hypothesis? It was the mean sale price was 90,000. My observed statistics are I place under L1, keep the frequency at 1. The alternate hypothesis was two-tailed, so I'm saying that my alternate hypothesis, the mu, is not going to be equal to the 90,000, so I had the first choice. And I can calculate. What do I need to record? The average sale price that I observed was the 85,250. And this allows me to jump all the way, not to my z-score, but to my t-score. So that is negative 1.13. And my p-value is 29%, 0.29. We know that as a high p-value. Okay, so the calculator allowed me to save many, many, many steps. So let me show you the steps that you would have to show if you did not have a graphing calculator. Okay, so we had a sample size of 8. The degree of freedom is always 1 less than the sample size. So the degree of freedom is actually labeled as 7. My X bar, my mean of my sample was 85,200.